This video is going to go over how to simplify a square root, or some people might say that a square root, they might say simplify a radical, but we're talking about radicals. The radical is this symbol. We're talking about radicals when they're specifically a square root. So sometimes when we go to simplify a square root, the number is a perfect square. And what it's asking is, what number times itself is 9? Well, 3 times 3 is 9, and so the answer is 3. We only write it once because we're breaking it down into what number times itself is that number on the inside. So here we would have 6 times 6 is 36. We would say the answer is 6. Similarly, the square root of 121, we're like, well, what number times itself is 121? Well, that would be 11 times 11, and so my answer would be 11. The next three I have here on the screen are not perfect squares. There isn't a number times itself that gives us these three radicals. And so what we're going to do here is we're going to break these down into what we call the prime factorization. We're trying to get a list of numbers multiplied together that are all prime that would multiply to be 150. So I'm going to start by just doing one that I know. I know that 15 times 10 is 150. And then I'm going to keep breaking it down until I can't break it down any further. So then 15 is 3 times 5, and 10 is 5 times 2. And now all of these numbers are prime. They can't be divided by anything but 1 in themselves. And this would be my prime factorization. I have a pair of 5s. So just like above, when I had 2 3s, I brought it out as 1 3. I'm going to square root 5 times 5. The square root of 5 times 5 is 5. And then I'm going to leave my 3 times 2 on the inside. And so then my final answer would become 5 times the square root of 6. Now, to check to see if you have done this correctly, you can type in your calculator the original square root problem, square root of 150. It's going to give you a decimal, an irrational number. Then you can type in your simplified version, and these two should be the same number. All right. So now, 72. I'm going to break this down. I might do 2 times 36 here. All even numbers can be divided by 2, so that's always a good strategy if you get stuck. I'm going to bring down my 2 because it's prime. I'm going to turn 36 into 6 times 6. At this point, although they're not prime, you can circle anytime you have a set of numbers and bring it out. And so my answer would be 6 root 2. Now I'm going to show you what would have happened had I maybe broken it down a different way and didn't notice that. So let's say I looked at 36 and I was like, okay, well that's 4 times 9. All right, well then bring my 2 down because it's prime. 4 is 2 times 2. 9 is 3 times 3. Now all my numbers are prime. I have a pair of 2s and a pair of 3s. And so I would have a 2 come out, a 3 come out, and then this one that didn't have a pair is left on the inside. The 2 that came out would be multiplied together, making 6 root 2, which is the same as this answer. All right, let's keep practicing. 200 is 2 times 100. Then I'm going to bring that 2 down. You always bring down your prime numbers. 100, you could jump to saying 10 times 10 and you'd be done. So I could say, okay, this is 10 times 10. I have a pair of 10s and a 2 left on the inside. Or, again, maybe you did it a different way. You didn't think 10 times 10. You might think, okay, well, what if you did, 4 times 25? Then bring down my 2. The 4 is 2 times 2. The 25 is 5 times 5. You would have had a pair of 2s, a pair of 5s. A 2 times a 5 on the outside would have made that 10, and then you still had this 2 left on the inside, and that gives you the same answer as that one. All right, let's do some more. Let's say we have the square root of something big. Let's do 396. All right, so maybe you're just not sure. There's no harm in taking your calculator and taking 396 and seeing if you can, well, one, you could see if it's a perfect square. And if it's a decimal, then it's not. Then you can divide it by numbers. I know it's divisible by 2, but let's see if it's divisible by 6. It is. Okay, so then I'm going to do 6 times 66. Just guessed and checked there. The 6 can become 2 times 3. 66 can become 6 times 11. And then we have one more phase of breakdown here. Bring down all your primes. This 6 is also a 2 times 3. And then this 11. If you were to multiply, the reason this works, guys, is that if I were to multiply all these prime numbers back, 2 times 3 times 2 times 3 times 11, I get the number I started with. That's why it's called as prime factorization. So now I'm going to circle my pairs. I have this pair of 2s, and I have this pair of 3s. So a 2 times a 3 is coming out, and I'm going to be left with the square root of 11 on the inside. And so then my final answer here would be 6 square root 11. And if I check that in the calculator, I get the same decimal as I did with the original square root. I'm going to do one more example. Let's do 756, a really big number. All right, so let's say I wanted to try dividing that by, we'll just go the long way. We'll do 2. So I could say, all right, well, this is 2 times 378. Bring down my 2, 378. And I'm typing this into Decimus on another screen, is 2 times 189. All right, well, that's not even, so I can't divide it by 2. So I'm going to try 3. 189 divided by 3 gives me 63. And then I'm going to see if that 63 can be divided by 3. And that gives me 21. And then I bring down my 2, bring down my 2, bring down my 3, bring down my 3. And 21 is 3 times 7. And so now I can see that I have a pair of 2s, a pair of 3s. So a 2 times a 3 comes out, and the 3 times 7 stays in. And then this would be 6 root 21. Hope this video helps.